Hi, welcome back to the breadboard. In previous videos we've had a look at various PLCs ranging from Arduino based products up through to Raspberry Pi and including full-fledged PLCs from Siemens and other companies. One of the biggest complaints I've had from a lot of my viewers is the fact that these are not certified devices from a programming perspective, and that they really shouldn't be used in certainly mission critical, but in most industrial applications unless they were. Now, whilst I have my own views about that, a product has been sent to me from PCWorx Contact. I have a starter kit right here that actually meets the criteria of what you've all been asking for. So this is the PCWorx Contact PLCnext. It is based on the controller, which is the AXC F 2152 controller. It's a ARM Cortex processor. It comes with a ½ gig of RAM, an 800 megahertz processor, dual core. The main module comes with 2 Ethernet port, SD card slot, and power connections, etc. It has a special bus that they call axial line that allows it to communicate with other devices that you can plug into that and extend its capability. The starter kit comes with a 8-port input and output digital I/O and a 4-port 2-in 2-out analog I/O, fully programmable and customizable on the analog between 4 to 20 milliamps, plus or minus 5, 0 to 5, 1 to 5, 10 volts, etc. So one of the nice things about this particular controller from PCWorx Contact is that it supports the IEC 61131 runtime system. So that's a industry standard environment for operational industrial control systems that if you work within it, it gives you a level of surety of reliability and interoperability, etc., etc. And not only that, is the whole runtime is there. It also supports the IEC 61131-3 programming environment. Now, out of the box, under Eclipse, it supports programming in C++ for some of the modules. You can also use Visual Studio with C#, and you can use the PCWorx Engineer that allows you to use other programming languages like Relay Ladder, Boolean, etc. And again, we'll have a closer look at those as we go through. The starter kit is a way of getting to know this new controller and some of its modules in a ready-built. This module that we're looking at right here is exactly as it came to me. It came in a box, but basically, they provide a carry bag with everything inside it for the starter kit. The starter kit, completely assembled on this board, was in the bag. You get a license for the cloud-based Profi Cloud for 1 year. Quick start guide, the Ethernet cable. You get a power supply adapter so that you can run it from, you get a wall wart with international adapters for different types of sockets, whether it be 220, 110, 240 volts, etc. For different countries, so different shape that you just clip onto the power adapter. All of the wiring is already done for you, and it has the controller with an SD card plugged into it. It's actually behind this little piece of paper here. It comes with an 8-channel digital input-output module, 24 volts, and it comes with a 4-channel, 2 inputs and 2 outputs analog I/O controller. What else is on the board here is we have a power switch. Now, this looks like it's a custom build from PCWorx for this starter kit, with an on-off. So you put your 24 volts into here, you can just turn the whole system off and on with the power switch. Everything is all wired through, nicely color-coded, etc. And we also get a potentiometer here, which is linked up to one of the analog inputs, and we have a row of 8 switches on its own breakout board too, which is wired into the digital input. The digital output is not wired to anything because there are status LEDs on it already to show you what's going on if you wanted to run up a small test program or something. This is all on a DIN rail, all on a solid aluminum clad board with a couple of clips just to prop it up on the bench. And all of this is part of the starter kit, so you don't have to get anything in addition to this to get going. You do need to, of course, provide your own laptop or PC for programming things, but everything else is pretty much here. Out of the box, it's got 2 Ethernet ports on here, and it's set up to run on a network 192.168.1.10. You can change that fairly easily, but to start with, you need to just hook up with that IP address so that you can go in, configure it, and then change it to some other network if you want to. This is available through RS Components as a complete starter kit, but you can also buy these and a whole bunch of other modules completely separately, and I'll provide a list of links in the description so that you can go and have a look for pricing, etc., because of course, depending on where you are in the world, prices will vary and availability or options may also vary. I'm not quite sure yet. This is not been released yet on the market. Anyway, so let's just go and have a closer look at this and some of the modules so that you can see what we've got. So this is the actual unit now, not just a picture of it. You can see here it's turned off at the moment. It comes with a Meanwell 24 volt 1 amp power adapter. I have the North American plug module put on here. It just slides off so that you can change it to whatever country you like. Comes with a number of modules available to it, including, looks like, Australia, UK, Japan, etc. Basically, just pull these out and show you. So you've got the angled, I think, for Europe. You've got the UK adapter, and I think this one is Australia and potentially Japan or something like that, unless, oh, I think that one might be the Australian one there. Anyway, these are the 3 it comes with, as well as the North American, so that's nice, makes it easy to distribute. Comes with a good quality Ethernet Cat5 cable. Comes with a really nice bag. Let me just zoom out here. The whole kit is actually included in the bag. Fits in there, so as a starter kit, if you wanted to take it to a college or to do some demos or tutorials and training, very easy to do so. It came completely assembled, and all of the modules were, as I said, already wired up. If I take this off a second and show you the back of this, you'll see, but on the back of here you can see how neatly this is wired up, very, very neatly, all cable tied up, all the wires nicely run on parallel, etc. And like I mentioned in the previous video, all of the cables are appropriately marked with on the cables with screen print, ink anyway, that designates their proper cable function and where they go and get plugged into. Let me just plug this back in again. The demo program is installed on here, so we'll just plug it in and let it start up. See, the power comes right on because I have it turned on. So it's booting right now. The red light under boot is flashing. These modules won't be doing anything until it boots up. Obviously it's running, loading up the Linux kernel. So still in the process of booting up. It's not gone into run mode yet. Okay, now we're in run mode, and now you can see the lights here sequencing through the way that I was describing it in the demonstration application. Now I can change the speed of that sequencing by flipping these switches. So that's all of them off, and it's in its slowest mode. First one on, goes a bit faster, 2 on, a little bit faster, 3 on, full speed. It doesn't read all of the switches in this particular example. Analog input output, this is this potentiometer. We were reading about 50% before, so you can adjust the input voltage going into the ADC by just tweaking this knob on here, and the whole power gets turned off here. Anyway, so that's the modules and that's the wiring. As I said, very neat, robust sample demonstration starter kit for anybody that wants it. So let's have a look inside these, I guess. So this is the main PLC pulled apart. You can see we've got the 2 Ethernet ports right here. Under here is the ARM Cortex processor. we have the power supply module here. The 24 volts comes in on these two pins right here. Bunch of capacitors for smoothing, etc. On the back of it, we've got a couple of buck regulators, probably for providing 5 volts and other supplies for various parts of the PLC, and also down on the field bus. And here on the main module, you can see here's the supercapacitor for the real-time clock. This is the axial line module connector that goes down to the DIN rail to connect to other modules. You can see very fine pitched set of pins here. We have the full-size SD card slot, which points up out of the module. That this is where you can change this. There's also a small micro SD slot here, which is probably containing the firmware and everything else for the module, and a couple of other miscellaneous components on the bottom here, and that's pretty much it. The connector here is for connecting through to a ground pin, I believe, when it plugs into the chassis here. There's two metal spring clips here, and they go through and would connect to the ground, the frame ground of the DIN rails if they were grounded. So one of the connections is here, and another one, I believe, is this one from the power module. Here's the connector that I was talking about, where you put your field wiring into here. You can either push these in, depending on your connector type, ferrule or solid wires. Would push in here, and you can release them by slacking them by pushing in with a flat bladed screwdriver into these little things. Fairly standard connector, but the way they've done this is they've allowed it to plug into this bus connection here so that it's easy to disconnect without having to undo all the individual wiring and everything, which is really nice. And a lot of these modules have these clear light pipes going down to what would be the motherboard, so that any status indications and things like that can be brought up to the top of the connector. In this case, there is only one tiny LED on here, which would indicate probably power on. There are more, obviously, indicators on the main module. So here they are. Here's the light pipes. So couldn't see them for a moment, but they're actually mounted on either side of the main board. See all the LEDs here. I might try and take the heatsink off just for a second on this one, just so we can have a quick look to see what's behind the cover. So here we have the analog board pulled apart, and what we have at the bottom here is the main analog board. On the bottom right, you'll see the analog drivers. These provide the 4 to 20 milliamps and voltage outputs to each of the channels for the outputs. On the top middle of the board, of course, is the axial line F connector that connects to the backplane that's on the DIN rails. And on the other side of the board, you'll find the Cyclone III interface chip. The three connectors that you can see that are around the board there are actually for a daughter card, which provides additional power supplies for the analog circuitry. This board is completely isolated from the backplane and the Cyclone. At least the analog output and inputs are all isolated from the backplane, so that you have extra security for your PLC. This is the same board with the power supply module put back on. It sits on top of the Cyclone III processor. And these pins that you can see on the left hand side here are what connect to the field bus wiring. What you can see now is the FPGA side of the digital 8 input 8 output board. There is no daughter card for this, but you can clearly see the line running around and across the board that provides the isolation barrier. These two chips that straddle that line are the digital isolators. They're 4-channel isolators, and on this side of the board you can see a third isolating chip providing complete isolation from the actual 24 volt I/O field bus wiring and the internal axial line bus logic controller chips and everything. What is also clearly visible here are the two large chips on the right hand side are actually 61131-2 compliant digital I/O chips for the PLC, which, you know, it just shows what Phoenix Contactors got, length they've gone to build this, where they've actually selected chips that are already right out of the gate 61131 compliant. So it makes for a very robust product. Okay, so that basically completes the initial overview of the PLCnext technology starter kit, and a quick look inside the modules, clearly seeing that they are very well built. Couldn't find any bodge wires or anything like that. A lot of effort gone into these products to make them 61131-2 and -3 compliant with the software and the hardware. The starter kit is nicely put together. Nothing to stop you adding your own I/O like LEDs or other relays and some sensing devices to this and creating your own program. In a separate video, we will have a look at the sample program that is downloadable from the Phoenix Contact community site, and then we will also look at adding Node-RED and other applications to this. I'll show you in a set of how-tos how to complete each of these tasks and get them running so that you could communicate with other products and even heterogeneous ones from, say, Node-RED running on a Raspberry Pi, and maybe a Modbus HMI device and a few other things. We'll also look at running the OPC UA interface as well, which I struggled a little bit to figure out how it was working, and when I go to do that video, it'll become very clear what I had to do to actually get it working. I used a Node-RED OPC UA module on a Raspberry Pi as the client side and talked through secure channels to the PLCnext controller to extract data and write to I/O and analog ports on the unit. Anyway, that's for another video. So for now, that's it. I don't want to make this video too long, and I will see you in the upcoming videos for more in-depth look at how to use these products.